Good morning, students. Today we are discussing about some problem based on types of functions. We already studied about the type of function. The functions are one, many one, onto, and into. All those functions which are one and onto both are called bijective function. So one question is given there. Show that the function f from r star to r star defined by fx equal to 1 upon x is 1 and onto, where r star is the set of all non-zero real numbers. The first part of the question is that. Now second part, is the result true if domain r star replaced by set of natural number but codomain remains same. So now how can we solve this? Since fx equal to 1 upon x, this is the equation. Let x1 and x2 belongs to r star, this is domain. We take 2 points x1 and x2 of domain such that fx1 equal to fx2. This implies that 1 upon x1 equal to 1 upon x2, that means x1 equal to x2. So f is 1. Now let y belongs to r star codomain. What is the condition for proving the function is onto? The basic definition of onto function is saying that each element of the codomain should be the image of the element of domain. So here we choose any arbitrary point of codomain. Then there exist x belongs to r star domain such that fx equal to y, 1 upon x equal to y, that means x equal to 1 upon y. So x equal to 1 upon y is the element of r star domain. Here f 1 upon y equal to 1 upon y. So f is onto. The first part, fx equal to 1 upon x, this is given. We take here 2 points x1 and x2 from the domain having the property fx1 equal to fx2. According to definition, 1 upon x1 equal to 1 upon x2. This implies that x1 equal to x2. So each element of domain having the different image in codomain. This shows that f is 1. Now for proving this function is onto, we take 1 point y, any arbitrary point y from the codomain. Then there exists, then according to definition of onto function, there exists a point x belongs to r star. This means domain such that fx equal to y. If function is onto, then there should be a point in domain whose image will be is this point y. So according to this, we have fx equal to y, but fx equal to 1 upon x. So 1 upon x equal to y, the value of x is 1 upon y. That means for each y of codomain, there exists 1 upon y in domain whose image is y. So this shows that f is onto. Now, new function is f n to r star. Let x1 x2 belongs to n such that fx1 equal to fx2, that means 1 upon x1 equal to 1 upon x2, x1 equal to x2. This implies that f is 1. But if 3 belongs to r star codomain, then there exists, but then there is no value x equal to 1 upon 3 in n for which f 1 upon 3 equal to 3. This is the set of real numbers, non-zero real numbers. If we choose 3 is there. So according to definition, we want to 1 upon 3 in domain, but domain is the set of natural number. So then there is no value x equal to 1 upon 3 in n for which f. So f is not. This is the first problem of your NCERT book, in which we want to prove this function is 1 1 on 2, but if the domain is changed, the function is 1 1 but not on 2. Thank you. Now I am taking one more problem based on type of function. The function is defined f from set of natural number to set of natural number such that fx equal to x square. We want to discuss injectivity and surjectivity this question. The function is 1 1 and on 2 or not. So how can we solve this? Since fx equal to x square, let the first we discuss about injectivity 1 1. Let x1 x2 belongs to n such that fx1 equal to fx2, that means x1 square equal to x2 square. This implies that x1 equal to plus minus x2 or x1 equal to x2 because x1 x2 belongs to n. So negative sign can be left here. So we have taken 2 points x1 and x2 of the set of natural number domain having the property fx1 equal to fx2. According to definition of the function, fx equal to x square, so fx1 become x1 square equal to x2 square, x1 equal to plus minus x2, but minus sign is reduced there due to the x1 and x2 are the set elements of set of natural number. So this shows that f is 1 1. F is 1 in Z. onto surjective. Now we discuss the function is surjective or not. For it, let y belongs to n codomain. Then there exists x belongs to n domain such that fx equal to y. Here we want to prove the function is onto or not. For it, we take any arbitrary point formula from the codomain. According to definition of onto function, if y is the element of codomain, then it is compulsory there will be a one element in domain such that the image of this point will be equal to y. But fx is x square, so x square equal to y, x equal to plus minus root y, x equal to root y, not belongs to the n for some y. So f is not on. For example, if 2 belongs to n codomain, then root 2 not belongs to n such that f root 2 equal to 2. If we take 2 belongs to n in codomain, then under root 2 not belongs to n such that f root 2. Because if this function is onto and we choose one point in codomain and 2, its p-image will be root 2, but root 2 is not the element of the domain. So this shows that function is not on. Thank you. Now students, one more problem based on types of function. So in previous some problems we have so that the given function is 1 1 or not 1 1 onto or not onto. The basic concept for we want to prove the function is onto or not, it is confirmed that if range of the function is equal to the codomain of the function, that means the function is onto, and if range of the function is proper subset of the codomain, in this case the function is not onto. Now we start with one more problem. Show that modulus function f set of real number to set of real number defined by fx equal to modulus x equal to x if x greater than or equal to 0 and fx equal to minus x if x less than 0. This is the basic definition of the modulus function, is neither 1 1 nor onto. So how can we solve this question? Since fx equal to mod x 1 1, we start with 1 1, that means injective. So first we check injectivity of the function. Let x1 x2 belongs to R domain such that fx1 equal to fx2. This implies that x1 equal to mod x2, x1 not equal to x2. For example, f minus 2 equal to mod minus 2 equal to 2 and f2 equal to mod 2 equal to 2. Here f minus 2 equal to f2 but minus 2 not equal to 2. So f is not 1. Now we check on 2. Since fx equal to mod x is always the set of non-negative real numbers. Set of non-negative real numbers. So in this case, range of f is the proper subset of codomain of f, because the function is defined from set of real number to set of real number, but according to the definition the value of mod x is always non-negative. That means negative real numbers are not with the image of any element of the domain. So this implies that f is not on. So in this question, there is a modulus function. We want to show that the function is neither 1 1 nor on 2. For 1 1, we have two elements of the domain having the property fx1 equal to fx2. So mod x1 equal to mod x2, but x1 not equal to x2. We shown by this example. F minus 2, that means mod minus 2 is equal to 2. Similarly, f2 equal to also 2. So image of f minus 2 and f2 are both are equal, but minus 2 is not equal to 2. That means f is not 1 1. Now we want to check that the function is on 2 or subject to or not. So in this case, we have clearly seen the modulus, the value of the function, modulus function is always the non-negative real numbers, and in this case our range is the proper subset of the codomain. That means the function is not on 2, because in this case some real numbers, some negative, all the negative real numbers are not the images of the element of the domain. So this function is neither 1 1 nor 1 2. Thank you. Now I am taking one more problem based on types of function. The problem based on the signum function. We already studied about signum function in class 11. Show that the signum function f from set of real number to set of real number defined by fx equal to. There are three values of fx. The images fx equal to 1 if x greater than 0, 0 if x equal to 0, and minus 1 if x less than 0. So we want to prove that this function is neither 1 1 nor on 2. Solve. First, we check that the function is 1 1 or not. We start with let x1 x2 belongs to set of real number which is domain, such that fx1 equal to fx2, but x1 not equal to x2. For example, let x1 equal to 3 and x2 equal to 4. So f3 equal to 1 and f4 also equal to 1 according to definition of the function. Fx equal to 1 if x greater than 0. So if x is 3, that's the value of f3 is 1, and if x equal to 4, then f4 also equal to 1. Here f3 equal to f4, but 3 not equal to 4. So f is not 1. Now we discuss about 1, 2. It is clear that if range of the function is proper subset of the codomain, that is function is never onto. Here f r to r is a signal function. So range of f equal to set -1 0 1 according to the definition of the function. The range are -1 0 and 1. This implies that range of f is the proper subset of set of real number. This implies that f is not 1. So signal function is neither 1 1 nor 1. Thank you. Now I am taking one more problem based on types of function. The problem is prove that detached integer function, you are well aware about the detached integer function, f set of real number to set of real number defined by fx equal to detached integer function x is neither 1 1 nor onto, where bracket x denote the detached integer less than or equal to x. Now how can we solve this question? Since fx equal to detached integer function x, this is the definition of this function. First we check that the function is 1 1. Let x1 x2 belongs to R domain such that fx1 equal to fx2 but x1 not equal to fx1 equal to fx2. That means bracket x1 is equal to x2. This implies that x1 not equal to x2 because (2.3) is equal to 2 and 2.7 is equal to 2. So here f 2.3 equal to f 2.7, but 2.3 not equal to 2.7. So f is not 1. Onto. Now we check the function is onto or not. Since fx equal to mod x is always an integer value. Since fx equal to bracket x is always an integer value, but column n is equal to r, this implies that range of f is the subset of r. This implies that f is not onto. We want to check that the function is onto or not. Fx equal to greatest real function x. We well aware the value of greatest real function x